Hello, welcome to Mathematics Catalyst. Today we are discussing about the simple identities which are belonging to the trigonometry portion. These are the fundamental identities of trigonometry. Trigonometric identities. First of all, we know about all the trigonometric ratios as this is our triangle ABC and this is our angle theta, right? So we know that sine theta is equals to perpendicular upon base. This is our perpendicular. This is base, right? And we are giving it as B, and perpendicular is taking as P, and third one is hypotenuse. We are taking as H, right? So P upon H is sine theta, and cos theta is equals to B upon H, that is base upon hypotenuse. Third is tan theta. Tan theta is nothing but it is P upon B. And obviously cosec theta is the reciprocal. Cosec theta is the reciprocal of sine theta. So we can take it H upon P. And secant theta is reciprocal of cos theta. So we can write it as H by B. And cot theta, cotangent theta is the reciprocal of tan theta. So it can take me as V upon P. In this way, we can correlate these all six trigonometric ratios. And after all, we can say cosec theta is equals to 1 upon sine theta, because here we know that cosec theta is the reciprocal of sine theta. So this is P upon H and this is H upon P. Therefore, we can replace it as cosec theta is equal to 1 upon sine theta. Or you can say sine theta is equals to 1 upon cosec theta. Usually, when we use these type of identities in our questions, then we have to convert cosec theta into sine theta basically. So cosec theta is equals to 1 upon sine theta. After that, secant theta. Secant theta is 1 upon cos theta, or we can say cos theta is equals to 1 upon sec theta. And at last, cot theta is equals to 1 upon tan theta, or we can say tan theta is equals to 1 upon cot theta. In simple way, we can say that cosec, sec, and cot theta are the reciprocals of sine theta, cos theta, and tan theta, respectively. Right? After taking these identities, we will also discuss that our next identity is sine square theta plus cos square theta is equals to what? We know that sine square theta plus cos square theta is equals to 1, but we want to show this result also. So sine square theta plus cos square theta, whenever you put the value of sine square theta plus cos square theta, as we know, sine theta is equals to P upon H and cos theta is equals to B upon H, right? We are taking the square of both, P square upon H square, B square upon H square. Whenever you take its LCM, that becomes P square plus B square. But in the right angle triangle, we know that P square plus B square is equals to H square by using Pythagoras theorem, right? So by using Pythagoras theorem, we know that the value of P square plus B square is equals to H square. So we can replace here H square and these two terms will cancel out and we obtain sine square theta plus cos square theta is equals to 1. This is our next trigonometric identity and we can use this trigonometric identity in three ways. Basically sine square theta plus cos square theta is equals to 1, or we can say cos square theta is equals to 1 minus sine square theta, or we can say sine square theta is equals to 1 minus cos square theta. There are the three ways by which we can learn this identity. Either sine square theta plus cos square theta is equals to 1, cos square theta is 1 minus sine square theta, or you can say sine square theta is equals to 1 minus cos square theta. And after all, next is we know that secant square theta minus tan square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. But how? Same, in the same way, sec theta may be expressed as h by b, right? And tan theta is written as p by b, perpendicular upon base, and then solving it as discussed above and taking the LCM b square, we obtain h square minus p square. And h square minus p square becomes h square minus p square becomes b square by using again Pythagoras theorem, and this becomes b square. So b square upon b square will cancel out, we obtain 1. So sec square theta minus tan square theta will be 1. Or this identity can be taken as secant square theta is 1 plus tan square theta, or tan square theta is equals to secant square theta minus 1. So we can also learn this result in two different ways. That is, secant square theta is 1 plus tan square theta, or tan square theta is equals to secant square theta minus 1. And similarly, we can obtain this result also. Cosec square theta minus cot square theta is equals to 1. You can do this result also. Cosec square theta minus cot square theta is equals to 1. And in similar way, you have to substitute the value of cosec theta. Where is cosec theta? That is h upon p, and cot theta is b upon p. And when you put these values, then taking the LCM and use the Pythagoras theorem in same way, then we obtain cosec square theta minus cot square theta is equal to 1. It is leaving for you as an exercise, and cosec square theta is 1 plus cot square theta, and cot square theta may be expressed as cosecant square theta minus 1. In two other ways, we can express this identity as cosec square theta is 1 plus cot square theta, and cot square theta is equal to cosec square theta minus 1. Basically, in trigonometry, we have different kind of identities, and the huge amount of identities are there, right? So there are many more identities, but we are taking the fundamental identities which are belonging to your 10th class. So first of all, you should go through these identities, then we will take more identities also in our next video. Please wait and watch one by one. Thank you.